For our second lesson on density, you will be able to understand the mathematical relationship between density, mass, and volume. Density equals mass divided by volume. So let's look at this beaker of water. It has a volume of 46 milliliters. 46 milliliters of water in the beaker. Now let's put it on the triple beam balance and get the mass. The mass of the water turns out to be 46 grams. So to calculate the density, density equals mass divided by volume, 46 grams divided by 46 milliliters. Density is equal to 1 gram per milliliter. Let's look at a different example. Now this beaker of water has a volume of 76 milliliters. That's the volume. That's how much space it takes up in the beaker. Let's put it on the triple beam balance, and we see that the mass of that water is also 76 grams. Now let's calculate the density. As we recall, density equals mass divided by volume equals 76 grams divided by 76 milliliters equals 1 gram per milliliter. And we can see that it has the same density as the other jar of water that we looked at. And that is because density is an intrinsic property. It doesn't matter how much of the substance you have, the density stays the same. 1 cup of water has the same density as 1 gallon of water, 1 gram per mil. So no matter where you go in the universe, if you find water and you calculate its density, whether you use a little drop or whether you use a whole bucket, if you take the mass of your water and you divide it by the amount of space that it takes up, it will always be 1 gram per milliliter. That is the density of water. Say we had a box, and that box was full of those little crunchy plastic packing peanuts. And the volume of this box, this amount of space that it takes up, is equal to 5,700 milliliters. Now, what if we were to put this box on a scale and we get the mass of the box, and the mass of the box is 1,435 grams. All right? Now, to calculate the density, density equals mass divided by volume. So density will equal 1,435 grams divided by 5,700 milliliters. And when you do the math, that equals 0.25 grams per milliliter, the density. Now let's take that same box, so it has the same volume, 5,700 milliliters, but instead of filling it with those light packing peanuts, let's fill it with a bunch of rocks. Alright, so now when we take the mass of the box, even though it has the same volume, its mass is a lot heavier because I filled it with rocks instead of those packing things. So the mass is 2,653 grams. So how will this affect the density? Well, density is mass divided by volume. 2,653 grams divided by 5,700 milliliters equals 0.47 grams per milliliter. So in our first example, when the box was really light and the volume was 5,700, our density was 0.25. But in our second example, when we made the box heavier and we kept the volume of the box the same at 5,700, that density was almost twice as much. It was 0.47 grams per milliliter. So that shows us that if you hold the volume constant, that means if you keep the volume the same, then increasing the mass will increase the density. But what if we decrease the mass? If we decrease the mass, then let's go back to our first box, the box full of the packing peanuts. Its volume was 5,700, its mass was 1,435. If we calculate the density, mass divided by volume, density is 0.25 grams per milliliter. Alright, so we got that. Now, let's decrease the volume of our new box. So we're going to take all of our packet peanuts and we're going to put them in a smaller box. And since these are made out of like those little plastic things, we can squeeze them in there and we can crush them all in there so that they all fit into a tiny new box. Now, the volume of our new box takes up a lot less space. It's only 1,700 milliliters. The old box was 5,700, but the new box was 1,700. Now, the mass of the new box is the same because we took everything inside the old box and we squeezed it in to the new box. So the mass of the new box is 1,435 grams. Now, the density. Density is mass divided by volume. So in this case, it's going to be 1435 grams divided by 1,700 milliliters. And that will give us 0.84 grams per milliliter as the density, which is almost 3 times as much density as the previous example. So it tells us that if we hold mass constant, if we keep mass the same, then decreasing the volume will increase density. And by contrast, what if we were to increase the volume? Well, that would decrease density. So we saw that if we hold volume constant, if we increase the mass, density will increase. But if we decrease the mass, density will decrease. Now, what if we hold mass constant? So with constant mass, if we increase the volume, density will decrease. But if we decrease the volume, density will increase. Now, we know that if we increase the mass, density increases. We also know that if we decrease the volume, density increases. So what if we did both at the same time? What if we increase mass and decrease volume? What would happen is density would skyrocket. Density would go way, way up. Now, the next example, we know that decreasing the mass will lower the density. And we also know that increasing the volume also lowers density. So what if we did both at the same time? Lowering the mass but increasing the volume at the same time would greatly, greatly lower the density. Now, what if we increase both mass and volume at the same time? We really wouldn't know what would happen to the density. We need more information because density could increase or decrease depending on which was increased more, mass or volume. Same thing for if we decrease mass and decrease volume at the same time. If we did that, we wouldn't be able to figure out what happened to density. We need more information.